Good afternoon. I work in the Belgian office of Cisco, but I am from St Petersburg and therefore I do my report in Russian. I do not do reports in Russian very often. I'll speak about the deployment experiences of IPv6 on Wi-Fi networks. Those people who works with IPv6 in their networks. Okay, so 10 persons. Who does have a smartphone? Almost everybody. But I suppose that at the first question there should be more answers. Yes, because approximately 60–70% nodes working on Wi-Fi have IPv6 support. So they can work at IPv6 protocol. I'm going to speak about a network, is conference network, Cisco Live. The network is a big one, 300 access points, so over 1,000 connections at one time. And we have experience which can be applied to bigger or smaller networks. It is a conference network, so we have some peculiarities. We have a very short life cycle. Moreover, I can say that wireless is the only access point. It is very critical for it to work without any breaks for all our visitors, even not to note that they use IPv6, because the end users should not think about the IP protocol they work at their network. So the main ideas of design, that is the one segment, because people move, and planning the address area should be quite simple. Moreover, there is a centralized principle, so we have several controllers, and we manage the whole network through them. This centralized approach with a one segment leads us to the fact that we should follow some aspects like the limiting of multicast traffic. If we have several thousand nodes, multicast traffic should be limited. And we should follow the IPv6 neighbor discovery protocol, and I'd like to tell you why we should do. Before we start doing it, let's make a short overview. What happens at a new connection of IPv6? So when we have a link, then the host link local IPv6 address is set. Then the host should duplicate address detection and check whether this address has already been existing. If no, then the host sends a request for getting the router solicitation. Then the router gives the advertisement, and beside this information there is some more data, that is prefix which router serves at this segment. It is very important. At the IPv6, it is a new tool of connection, a new Slack tool which gives the host an opportunity to get prefix 64-bit and then get address which can be globally routed. Before the host uses this address, the host should check the uniquity of this address. The address is fine, but when we speak about the work of the network, we need the transfer of addresses into names. There is bit. If you install this bit, the host run the procedure of DHCP, CP, and then got the name of DNS server. That's it, almost. But there is another aspect. You can use a familiar tool from IPv4, where the addresses are controlled centralizedly. Usually, before you use the address, the host check the uniquity of the address. Looking at this process, the announce of router is a central package at connection of the host to the network. If there are problems, it is interesting to see what happens. The package is sent by multicast to all the hosts in the network. The goal is to optimize the connection process. So if hosts try to connect, you can send a package. The problem in the multicast network, though the packages arrive rather early, the problem is that the packages should be sent to all the hosts at the same time. This leads to occupying of the line, and this leads to the lower productivity of all the clients at the network. There was an interesting function which limits the multiple broadcast advertisement and limits the number of packages per minute. If this number is bigger, then they are transfigured into unicast. The packages are transfigured in the unicast. It is a useful tool from the point of view of routing. Let's speak about the security of neighbor discovery protocol. Unfortunately, I don't have my demo file. It is in another presentation, probably. I will tell you about it. At getting of the router advertisement package, some software can configure parameters which are not the same as the parameters which are in the network. So, if you configure a network for IPv6 and a new router in the network does not have these parameters, these settings, router sends router advertisement. The host thinks that the network should be transfigured. If the parameters are wrong, the host makes the DNS IPv6 configuration and can even set the addresses in another way. Besides this, the protocol neighbor discovery is used for checking the uniquity of the address. How it works? Let me explain you. Before using the IP address, the host sends a request at the segment and checks the uniquity of the address. If there is if there is the same address already existing, then it asks to reply at this request. And if there is no reply, then host starts to use this address. Let's speak about the probable attack at this protocol. We can wait till the host sends a request on uniquity of the address, and we can say, yes, it's mine. Then the work of host cannot be done through IPv6 because the host cannot use this address. Depending on what mechanism of address identification, it will be either try to run the DAD procedure or to get another address. But host C at the slide can reply to all the requests. So the attacking side can just switch off the IPv6 stack at a certain host. And another function of IPv6 neighbor discovery, that is the configuration of IPv6 into Ethernet address to send the packages of the Ethernet level. That is the exchange of two packages. So our request, neighbor solicitation request, and then this package initiates the getting of neighbor advertisement package as a reply, and the requesting host can set a log in the chart and start the connection with the host. But at this procedure, there can be a third host who can send neighbor advertisement, which will lead to the updating of the neighbor cache chart. So there will be the address from the C host and not from the B host. So all the packages will go to the C address. So the situation is similar to the situation with protocol R at IPv4. How can we protect us from this? We should check the that the Ethernet address and the address are the same. So we must see what hosts started to use this address. How can we define it? By following the DAD packages and DHCP traffic. We can make a chart which gives us the idea at which Ethernet address IPv6 address is located. If we get the reply from a known host, then we can, from Wi-Fi infrastructure or switch, we can make DAD exchange and request the host whether it has this IPv6 address, and then we can put in the log in the chart.
So if there was no exchange, then there is no such an entry in the table, and so we can stop transition of packages from the host. So if packets are going from the address which was not legitimate, means spoof addresses, then these addresses wouldn't go through Wi-Fi. And as an example, it is actually IPv6 only segment. We don't have IPv4 address, and We have a wireless LAN controller actually tracks those addresses assigned to customers. So such approach enables us to avoid spoofing with our wireless clients. And this possibility appeared quite recently. Officially, it appeared last year. And from the point of view of large networks, like enterprise networks or large conferences, it quite considerably eases our job, because that part of a job which is related to actually catching those computers that sends wrong or incorrect packages. Actually, we don't need to do it anymore. And a couple of words about this mechanism with while the entries when we initially put in an entry into the table, they're written down in a reachable status. That in some time, in 5 minutes, by default, those entries became stale, and in that condition, they are checked time and then with a neighbor discovery mechanism. So we check if the host with its address is still alive. So it makes possible for us to store, to hold a snapshot of the network, which corresponds to the current addresses in the network with our clients. And the second video is not here either. So that's what I would like to say at the end of the road. So today, from the point of view of possibilities of the capacity of the equipment, from the point of view of practical capacities of IPv6 in production networks, well, I don't see lots of issues. The issues have been worked out, and today we can already start using them in real networks. So it's sad. It's not that a bit but it's not that hard thing to do. Array guard and source guard, we need it in any network. If this network is not in the trusted domain, I mean, if not all the clients in this network are trusted ones, so it's quite an interesting capacity, which makes possible to provide security in IPv6 networks at the same level as in IPv4 ones. That's all I want to tell you, and thank you. So, dear colleagues, if there are any questions, you are free to ask. So, such a long presentation, no questions. Okay, good. Thank you. Looks like there is one question over there. Dmitry Kakhmanuk, hostmaster. Could you tell me, please, which equipment you can recommend with support for this array guard and source guard, except for Cisco? Maybe something else? Thank you. It's quite a complex issue. As a network engineer, I usually work with equipment which is produced by my employer. So we might ask to the whole audience. So once you have IPv6 deployment, that's going to be very interesting to hear next time they talk about this topic. And so, dear colleagues, any practical experience on implementation of IPv6? Not the history about why we need it, why it cannot be implemented, but any practical experience is always welcome. So if there is any case of deployment, we will be great to accept this talk. The presentation. So we are going to, I don't know if we succeed with it, but we have a prepared solution for the Enog network, which is going to be in Kiev. So we're going to use OpenVRT for that. Another question? Yes, please. Well, actually, I want to continue the question to Maxim. So, Maxim, how are you going to analyze, in particular, how are you going to suppress this unsolicited, unsanctioned arrays? Well, there are two answers: long one and short one. Short one, no way. We can't do that. Second, the long one, we should try to use other technologies. We can do it, but actually there is no effective system to, so to say, suppress them, to get rid of them. But through Enog, I think Maxim will tell us about the results. Well, I can add up to that. Well, now from the point of view of suppressing, to say suppression, there are two ways we can assess the system. One approach, those arrays which are accident. For instance, if you have a laptop and this laptop has a terminal connection sharing, and according to the standards, the laptop should send these arrays. And the second thing is those arrays which are sent by those evil hackers using special hackers instruments. Then at the moment, from the point of view from the industrial point of view, the standard solution is just to block this network fragments and undetermined transport. There is a solution, though it's not the standard one. There is still a discussion how actually to use it. So it can be used. We can block them. So if there are protocols using fragments, then these protocols are going to be in the network. Then they will be broken. If you don't use those protocols, then from practical point of view, it's possible to block it. Okay, not only our program committee, not only steering committee. So a short note. Actually, if there is an evil actions there with errors, then it's impossible to fight errors because MAC changes. If the attacker has access to your media, you can't do something. You can't do anything with that. That's a full stop. If there is no evil actions, that is a good idea, great implementation from Cisco, and it would be great to know what other vendors can do, especially OpenVRT, and also regarding the IPv6 deployment. It's most interesting to listen to not to success stories, but to, so to say, opposite ones, so to say, to non-success stories, which were the issues, because it's much nicer to learn it on other mistakes than on mistakes of your own. And one more question. Workflows that is clear that in these schematics, Wi-Fi equipment by Cisco is considered like edge equipment. So it's the nearest, the closest line, the first protection line. What about the access level commutators? Will we have such mechanisms at some point of time? Well, everything. The thing is. It depends on those access switches. It depends on model. The latest access switches they might not have it, but with others, I think they have it. We can discuss it with you. I can share the links to the materials which exist in this respect. So dear colleagues. So there is no more time for questions. Maybe a final, last comment. Tletnikov Alexander, let assist. We asked about your question about the problem. Talking about the DHCP v6. The story that DHCP v6 works on MAC address. It's not actually a true one, because the DHCP v6 works using ID, which is sent by client, which sometimes can be equal to a MAC address. Sometimes it can be equal to a MAC address of this internal interface, and sometimes it's going to be a function of the weather on Mars. So thank you. Well, I would like to comment on that. Since we work with the second level devices, then DHCP packages, they go with the source MAC address of the particular device. But we can discuss it. So dear colleagues, let's with this discussion.